Hello, ladies and gentlemen, and welcome to Distance Learning. So this is lesson 8.2, and that'll correspond with section 8.2 in your textbook. We're going to be representing quadratic relations in two different ways, and you need to understand right off the bat that you cannot do this lesson unless you can factor a trinomial. I have posted the video lessons for section 7.4, and if you have not reviewed those, if you haven't gone and done that, stop this video now, go watch those videos and try them and do the examples and make sure that you can, and then come back here and you'll be able to do this one. But without that, you're going to be lost here. Okay, so representing a quadratic relation in different ways. First of all, there's a bit of a typo here. There should be an a in front of this x squared. So that should be y equals ax squared plus bx plus c. That is called standard form. And this form here, y equals x minus r, x minus s, is going to be called factored form. So once again, this is going to be standard form. Looks like that my standard form. And this is going to be called factored form. And you can tell that this is a quadratic, and this would be a quadratic. Actually, it is a quadratic, but it would look like this if we were to expand it. It would be x times x, which would give us our x squared. There we go. Now, the a, b, and c are numbers, so it might look something like this. Oh, all my pens have kind of dried up on me. Let me get another one over here. So this might be y equals 5x squared plus 3x minus 7. So there's an example of a quadratic in standard form. The a is 5, the b is 3, and the c is negative 7. And here's an example of a quadratic in factored form. And see the negatives here? So that means that the r is positive 3 because the negative stayed. And see how this is a positive here, but it's a negative in the formula? Well, the only way that works, if you have a formula that looks like this, so in this one, if r is equal to positive 3, and if s is equal to negative 2, look what happens. We get y equals x minus positive 3, and we get x minus negative 2. So the s went in, the r went in. Negative times positive is a negative. Negative times negative is a positive. So what happens is when you're looking at this, the r is actually equal to positive 3, and the s is actually equal to negative 2, and that's how that became a positive. So we're going to have to keep that in mind as we're going through this. Okay, so we've made this typo here, ax squared plus bx plus c, and that's in factored form. Let me just bring this into focus a little bit more. So for a quadratic equation of the form x minus r and x minus s, I'm going to tell you right now that the x-intercepts are going to be the r and the s value. What that means is that if I have a quadratic and it looks something like this, its x-intercepts, we could say maybe this is 5, 0, and maybe this one is negative 2, 0. These are the x-intercepts. This would have an equation that would look like this. Since the x-intercepts are negative 2 and s is 5, those are your x-intercepts. Okay, those are the x values where it crosses the x-axis. So this would be y equals x minus negative 2, x minus 5. It would be x plus 2, x minus 5. So this equation gives us a quadratic with these x-intercepts. Now that's kind of interesting. And let's look at that just one more time. I'll get another piece of paper here. So it was, let's go to this stage, x plus 2, x minus 5. Now if I was to expand this, we would get x times x, which is x squared. X times negative 5 is negative 5x, plus 2x minus 10. X squared minus 3x minus 10. Remember, it's negative 5x plus 2x. They go together to give me negative 3x. So what we have here is a quadratic that is written in standard form. The same quadratic can be written in factored form. This is the same parabola. And since we know that these are my x-intercepts, one of the x-intercepts is going to be negative 2. The other one's going to be 5. So I know that it's going to be negative 2. The other one's going to be 5. This value of a equals 1, which is positive, which means we know this opens up. We know that the axis of symmetry has to be directly in the middle there somewhere. So our parabola looks something like this. Okay? All right. So we got some interesting stuff that's going on today. Okay, so back to the lesson. For a quadratic equation of the form ax squared plus bx plus c, the y-intercept will always be c. So going back to our example here, this parabola and this parabola are the same parabola. Notice that we have a c value here. Our c value is negative 10, which means that that's going to correspond with the y-intercept. And so this will be 0, negative 10. That point right there will be 0, negative 10. So I know my x-intercepts if it's in factored form. I know my y-intercept if it's in standard form. And I can tell if it opens up or down by the a value. We know that the axis of symmetry lies directly between these two x-intercepts. All right. Well, we also know the vertex is here, but we'll get into that later. Okay. The zeros of a quadratic relation are also called the x-intercepts. So, again, these are your x-intercepts. They're also called zeros. Now, let me show you why they're called zeros. Remember, we had this, y equals x plus 2, x minus 5. Remember, we said that that equaled this. So we have negative 2, 0, and we have 5, 0. So your x-intercepts are negative 2 and 5. What that means is that they cross the axis at negative 2, 0, and 5, 0. Well, they're also called the zeros. And the reason why they're called the zeros is because that's where y equals 0 for both of them. So when x equals negative 2, y equals 0, which gives you that point. And when x equals 5, y equals 0, so you get this point. So it's when these are equal to 0. It's when y will equal to 0. So the zeros of any quadratic are the values of x that will allow y to be 0. Now that leads us to some interesting algebra, because what happens then, if we think about this, I've got two things that are multiplying to give 0. Now let's just make an easier question. Let's say I have a times b equals 0. Let's think of some values that could go in here. If I have a times b, and if the answer to that product is 0, then one of these two, either a or b, or both, but at least one of them must equal 0. So either a equals 0 or b equals 0. If a equals 0, it doesn't matter what b is. It can be anything at all because 0 times b will be 0. If b equals 0, it doesn't matter what a is because anything times 0 will be 0. And if they're both 0, then great. 0 times 0 is 0. Now, what does that say here? Well, I've got two things. Consider one a, consider the other one b, equals 0. So if I've got two things that multiply to give 0, either, and you write that, either the first one equals 0, a equals 0, but in this case it's x plus 2 equals 0, or b equals 0, which is x minus 5. Now we want to isolate for x. We want to get x by itself. So we'll take 2 away from both sides. We're going to add 5 to both sides. And we find out that when we have x equals negative 2, x plus 2 is 0. And we find out when x is equal to 5, 5 minus 5 is 0. Which means these are the values that make this equation 0. Which is why the x-intercepts are called the zeros of the equation. Okay, I'm going to stop there because that video got a little bit long with the introduction, and then we'll come back and we'll do example number 1.